Hello, everyone. I'm Samantha van der Merwe. We'll be speaking on predicting social unrest events in South Africa. And this is my thesis topic that I'm working with the University of Cape Town. So a good example of social unrest events are the manifestation of, it will be the manifestation of the fallism culture in South Africa. So for example, we had hashtag Fees Must Fall, hashtag Rose Must Fall, and hashtag Zuma Must Fall. And I'm sure, like, for the South African audience, most of us were impacted by some of these protests. And I could say I shamelessly also participated in one or two of these protests. And most of these protests that I've mentioned in this example are peaceful protests, but that's not always the case. In many cases, these can become violent acts. And in South Africa, from 2004 onwards, it has social unrest activities have actually been on the incline. And what has been surfacing more are the violent protests. And violent protests protests in general have negative impacts on an economy, and as well as they can cause damage to persons and properties, and they can also pave the way for more populist policies. To be able to anticipate these events could provide a lot of benefits to the public and as well as to decision makers. So decision makers can be able to find more efficient strategies for mobilizing resources, as well as they can be able to strategize and make better policies. And in terms of the public, they'll be able to identify and be warned areas where there's high unsafety, and this will increase the safety of the public. Okay, so why anticipate? Yes, that was why I anticipate social unrest events. So how did I end up doing this? So let me talk about the data set. The data set I used is GDALT. It's the global database of events, language, and tone. This is an open source database, so it's available to everyone, and how I accessed it was via Google BigQuery. And another feature of this data set is that it is machine coded. And to me, this is actually a big factor because we don't have to do a lot of the nasty NLP processes that come with it. So we already have our features already extracted from the text data. And the text data is actually 1,000 records that have been extracted from news media articles. And the number of events that it has is up to 300 events. And most of these events pertain to conflict. And once I extracted my data, the prediction problem took the form of a time series. And the time series was then fed to an ARIMA model and an LSTM model. So ARIMA is more the traditional way in which time series forecasting has been done. And LSTMs gained recent popularity in 2017, and they have been now described as being the future of time series forecasting. And these models are actually quite opposites of each other. So the reason why, so ARIMA makes a lot of linear assumptions about your data, whereas LSTMs don't make any assumptions about your data. And as we all know that neural networks can approximate any function very well. And the data and the problem we're trying to solve is quite complex. So can we actually predict social unrest? The answer is we can predict it much better with a much lower error rate, especially if you look at the performance measures that we use, which is the mean absolute percentage error and the root mean squared error. You can see that LSTM produced significantly lower error rates to traditional approaches, and I think the graph actually is more encouraging, because then you can see the pattern of how the power of LSTMs in predicting this. And this was real-time predictions. So the advantage of GDALT is that it's a real-time database as well. So when you want to take this further, you can actually implement it with not having that limitation, and you can implement a live awareness system that could actually work. And to me, what I'm planning to do as the next phase for this project is to make the data more useful. So maybe adding a location feature and breaking it down per event type so it's more actionable. And you can also experiment with other methods and other architectures. One, since I've got not a lot of time left, I think the more permanent architecture is the attention model, which is actually new. And attention layer can be added to the LSTM. And this actually enhances the performance of it by being able to identify what's more important and keeping that memory within it. And you also have your CNNs. And I will be presenting this at the poster session. So if you want to get into understanding more about the methods and how I went about doing this, because it's quite a creative way that I did it in order to get those results. So it wasn't necessarily just running a time series problem. Cool. Thank you.